Let's kick things off with a simple but absolutely critical truth in AI. Everything, and seriously, I mean everything, hinges on the quality of your data. If you get this stage wrong, even the most sophisticated algorithm is destined to fail.
So who's on the hook to make sure it's done right? You might think it's just the data scientists or the engineers, right? Well, not exactly. The ultimate responsibility for the governance, the control, the auditability, it all lands squarely on the shoulders of the AI project manager. Okay, let's dive into what that really means.
Today, we're breaking down the AI PM's playbook for data transformation. We're talking about how you, as a project manager, guide the entire process of turning that raw, kind of messy information into a seriously valuable, model-ready asset.
So here's our game plan. We're going to walk through 6 key checkpoints that you, as the PM, need to own. We'll start with the big picture challenge, then get into the nitty-gritty of cleaning, feature engineering, consistency, data augmentation, and wrap up with the one rule to rule them all: reproducibility.
Okay, first things first. Let's really set the stage here. What's the core challenge we're trying to solve? You know, it's all about creating a structured, repeatable process for turning that raw, messy stuff into something a model can actually learn from.
So when we say data transformation, what does that actually mean from your perspective as a PM? Look, this isn't about you writing Python scripts. Your job is all about control. It's about asking the hard questions. Can we do this again exactly the same way 6 months from now? Could an auditor follow our tracks? And are we totally compliant with all our data policies? That's your world.
All right, let's get into the first big operational step: data cleaning. I love this analogy. Think of it like you're pouring the foundation for a skyscraper. If that foundation has cracks, the whole project is shaky from the start. It's that important.
As the PM, your job is to make sure the team has a crystal clear, documented plan for all of this. You're the one asking, what's our strategy for missing values? What's the official protocol for fixing errors? Have we made sure there are no duplicate records? And the big one, how are we handling sensitive personal info, PII, to make sure we're protecting user privacy? You've got to have the answers.
Again, you're not in there scrubbing the data yourself. You are the governor of this process. You're the one who signs off on the standard operating procedures. You're the one who says, nope, not good enough, document every single step. And you are that final backstop, making sure everything we're doing is above board, both legally and organizationally.
Okay, now for the fun part. At least, I think it's fun. Feature engineering. This is where the real artistry comes in. Your team takes that clean data and starts crafting it into powerful signals that the model can actually understand and use.
And just look at the difference here. On one side, you've got the raw data. It's noisy, it's messy, it's really tough for a model to make sense of. But then on the other side, you have these beautifully engineered features. They're clean, they have real analytical power, and, this is key, they're tied directly to what the business is trying to achieve. That transformation is where the magic really is.
And your role in this magic trick? Well, you're the director. You're the one getting the data scientists, the subject matter experts, and the engineers all in the same room, talking the same language. You have to make sure every feature is based on actual domain knowledge, not just some weird statistical fluke. You also need to insist on documentation for everything, even the features we decided not to use. And maybe most importantly, you're the watchdog, looking out for high-risk features that might sneak bias into the model.
All right, so we've got clean data and some awesome features. We're not done yet. Now we have to talk about consistency. This is where scaling and transformation come in. And I know this part sounds a little technical, but trust me, if you get this wrong, it can quietly, completely tank your model's performance without you even knowing why.
So your team's probably going to use one of two main approaches here. You've got normalization, which basically squishes all the data into a range between 0 and 1. Then there's standardization, which is a bit different. It recenters the data around a mean of 0. Look, you don't have to be a math whiz here, but as the PM, you absolutely have to make sure the team's choice is written down and, justified. Why did we pick this one over the other?
Now listen up, because this is probably the most important rule on this topic. It is absolutely non-negotiable. Whatever scaling method you choose, it has to be applied in the exact same way across your training data, your validation data, and your test data. If there's any difference, you get something called data leakage, and it basically makes all your performance metrics completely worthless. This is a rule you have to enforce with an iron fist.
So what do you do when you just don't have enough data? It happens all the time, right? Well, that's where this cool technique called data augmentation comes into play. We're talking about creating new, synthetic data from the data you already have. It's a powerful tool, but, with great power comes great responsibility.
And your team might bring this up for a few solid reasons. Maybe your data set is tiny, or it's really imbalanced, way more of one thing than another. Or maybe you can't use a bunch of real data because of privacy rules. It's also super common in things like computer vision, where you need to teach a model what a cat looks like from every possible angle, right? So you create those angles yourself.
And here again, you are the gatekeeper. Your team says, we want to flip images and paraphrase text. You say, okay, that strategy is approved, but, and this is a big but, you have to demand proof that this new synthetic data isn't creating new, weird biases, or worse, that it's not somehow revealing real private info. This means you need a formal risk assessment and a paper trail, an audit log for everything. Okay, this brings us to the final piece of the puzzle, and honestly, it might be the most important one. It's the golden rule that ties everything else we've talked about together, and that rule is reproducibility.
Here's the bottom line. If someone, an auditor or a regulator, even a new person on your team, comes to you 6 months from now and asks, hey, how exactly was this training data set made? You need to be able to answer that question perfectly, with zero hesitation. Every single step has to be traceable, repeatable, and auditable. Period. No excuses. So how do you actually pull this off? It's not magic. You enforce good habits and modern tools. You mandate version control for data pipelines, just like you would for source code. You make sure every transformation script lives in a repository. You push for automated tools, and you demand documentation that covers the whole story, the lineage, the versions, the logs. This is how you move from a science experiment to a professional, industrial-grade AI operation.
So, let's just wrap this up with a quick checklist. As the AI PM, what's your goal here? To make sure the whole data prep process is accurate and compliant? Check. Systematic and collaborative? Check. Consistent and controlled? Check. Ethical and risk-aware? Double check. And finally, reproducible and fully documented? That's the big one. Check. If you can tick all these boxes, you're winning. I'll just leave you with this one last question to think about. We all talk about our AI models being these incredibly valuable company assets, right? But is the foundation that asset is built on, the data, just as solid and professional? Can you truly audit it from start to finish? That's the question you, as the AI project manager, need to be able to answer with a very confident, very resounding yes.